Okay, so now we're moving on to part B of the question, which is 45 degrees extension. Now what we can do, we can draw over the diagram. It's up to you. If you feel you could dive right into the calculations, you go through. I'm not stopping you, right? So we have the quads here, the kneecap or the knee joint, and then we have 45 degrees extension. We know that there's a foot there, 45 degrees, and we know we have an ankle weight here. So we already know that we have two forces acting, and it is the weight of the shank and foot, and we have the 15-pound weight, right? So remember in the question, they gave us the length of the shank and foot, and from the last question, we already know that it's 0.285 meters, right? So let's get this calculation going. So in the last question, we waited till the end to put the formulas together, but we could do it from now because we're advancing, we're doing this thing on, right? So we could say that the total moment is equal to F1 by D1 plus F2 by D2, because we know we're dealing with two forces. So let me say it had a third force. So where would I do? We would have put plus F3 by D3, right? With F being the force and D being the perpendicular distance. Now let me get on to this thing. So we know we had two triangles because we have two forces. So we could do this one first. So the first one would be, here's 45 degrees, and we want to find D1, which is the perpendicular distance. We know that F1 is the weight of the shank and foot, and we know that the distance of the shank and foot from the fulcrum would be 0.285 meters. I hope I'll correct me there, because that means you're paying attention, right? So let me label up and let's go. So this would, we'll put it as B, we'll put this as A, we'll put this as C. So what we're using, we know we're using sine rule, right? And we're using B over sine B is equal to C over sine C. Plug in with values. We know B would represent D1, sine B would, the angle change, so now sine B would be sine 45. C is the same, 0.285 over sine C would be 90 degrees. So once we transpose, we know that that would be 0.285 sine 45 over sine 90. So let me calculate this real quick, right? Let me do the sine first. Sine 45 by 0.285 is equal to that, and we know sine 90 is 1, so our answer is 0.202, and distance is in meters, right? So that's our first triangle done. Now before we start running through these things, remember there's another way you could calculate your perpendicular distance, but we're not going to do this one because I find there's a little extra stuff, right? But remember, you can always draw your line from your fulcrum outwards and then connect it to your weight. And the difference with this one would be that you have, oh yeah, you're not under, jeez, you would have to minus the angle here from 90 and get your angle here to work with this triangle, right? And well, in this case, because it's 45, here would be the same 45, here would be your right angle, and your length of your shank and foot would actually be under here, but you would still come back and you'd still get the same calculation here. If you don't understand what I'm talking about, sorry, you can always go back to the calculating perpendicular distances video, Right, so now that we have found the perpendicular distance d1 for force 1, which is the weight of the shank and foot, let's do it for force 2, which would be the 15-pound weight. Now we know that 15-pound weight is acting at the same distance from the fulcrum as the weight of the shank and foot, because remember, the weight of the shank and foot distributed all along the foot, and this ankle weight itself placed at the base of your foot here on your ankle. So it's working at 285 meters. The angle is 45 degrees, and the perpendicular distance d2, because remember this is force 2, let me label that F1, F2, right? So now we can calculate d2, right? Now we know that the distance will end up the same, but we still going through it because in your exam, in your worksheets, you will have to go through the whole thing, right? So I suffering with all you. Sine rule. B over sine B is equal to C over sine C. I will label up that triangle. We know that this is C, so this would be big C. This is B, so this would be big B, right? So we know that B is the same as D2. Sine B would be sine 45 is equal to C, which is 0.285 over sine 90. So we know that we'll get the same thing, so we'll just speed it up a bit and put D2 is equal to 0.202 meters. So now that we have the perpendicular distance, which was what we find in D1 and D2, we could plug it into this formula one time because we want to find the total exterior moment or external moment, or like we said in the previous, anti-clockwise moment. All of these things mean the same thing. They're representing the same quantity, so don't mix it up, don't feel there's anything extra. It's the same thing, right? So we can say the total or the sum of, well, in the last question we use anti-clockwise because of this motion, but in this one we can say exterior moment is equal to F1, which was the weight of the shank and foot, and we know the weight of the shank and foot was 40.3 newtons, by D1, which is what we calculate here, 0.202 meters, plus F2, which was the 15-pound weight, and when we converted it to newtons, because forces in newtons was 49.35 newtons by the same perpendicular distance, messed that up, 0.202 meters, right? So let me calculate this thing here now. So 40.3 by 0.202 is equal to 8.14 Newton meters plus 49.35 by 0.202, which is equal to 9.97 Newton meters. And now we could add this value to this one, which is 8.14, and we get the total exterior moment to be 18.11 Newton meters, right? So now we're gonna start using the format that you have to use in your worksheets, in your questions, right? So after we find external, we can now come back and say that the principle of moment states that the sum of external moments is equal to the sum of internal moments. Now this would be the same as what we always saying, which is the sum of external would be anti-clockwise is equal to the sum of clockwise. Stay with me here, right? So since we know that this is the same, then the internal moment would be equal to 18.11 Newton meters. So now when we're calculating the force the quadriceps has to generate, we know that since moment is equal to force by distance, the force would be equal to the moment over the distance. So therefore the force the quadriceps would have to generate, we could put F quads, subscript quads, is equal to the interior moment, because this is what the quadricep force generates, and the perpendicular distance, which is what they gave us, which was 0.038 meters. We could cross that off, and what we will get, right? 18.11 divided by 0.038, 476.6 newtons. Now you realize, moving from 30 degrees to 45 degrees, the force the quadriceps has to generate is more. So what you would think as a physiotherapist is, if we now starting out these resistive exercises, you want to start out at a degree that would be more favorable to the muscle itself, so that you don't damage the muscle. Because you don't want to tell the patient lift your leg to 45 degrees and show them to do that, and then their quadricep not strong enough, because remember, the quadricep injury is not strong enough to generate this force. So this is how the practical aspect and stuff comes into it, right? So now we move on.